So hey guys, welcome to Clear and Crisp Coding, and in this video we would be discussing the solution of Codeforces round 655 due to problem C, which was Omkar and baseball. So this was a really tricky type of problem which I also faced a first error, but then I was able to rectify. So let's get started with the problem. So here is the problem statement. You can read the problem, but if I explain the problem in simple terms without missing any important point, then the problem is something like this. So Patrick like to play baseball. So this is just a story part. So what does it actually mean is that some person played baseball and he scored some points in a season, and those points are incrementing one at a time. So that means in the first game he scored 1 point, second he scored two, and so on. So if we represent the score in the form of an array, it would be something like 1, then in the next it would be 2, then it would be 3. So this would be the representation of the score in the form of an array. So but after some time, but he found that these special character got exchanged. That means their order got missed. That means this 1 2 3 could have became 3 2 1, or like 3 1 2. So this got permutated. And now what we are given is we are we have to restore this order back. That means a sorted order, by doing a special type of operation. So we have to perform this special exchange. So in this, what we can do is we can select some sub array of this array and then reorder those element in any choice. This is a really important point, that we can reorder that sub array in any order, but the only condition is that the element which was already present at a particular position should not come at the same position after the permutation. That means each of the elements should be changed in their position. So this was the question, and here is some sample input. So let's get to the explanation. So we will be understanding it with some examples. So what we are going to do is, so if we see this, these are 5 examples which are totally independent of each other. So what we are going to mark is, so if array at I is equal to the I, that means array at first is equal to 1, then we would be marking it as a 1, that means it is a match. Otherwise you would be marking it as a 0. So because this would be helpful for us in the later time. So if we see this is same, so we can mark as 1, this is same, we are 1 1 and 1. So if we see in this, all the position are satisfied. Basically 1 here means is that there is a match and we don't need to perform any operation on these values. But later on we will be coming to some point that we have to change these also to get a more optimal answer. But so in this case, if we see, there is a proper match of all position, so we do not need to change anything. So for this the answer is 0, as given in the sample input output also. The answer for this test case is 0. Now let's come to this question, this part. So if we see 1 and 3, these are not equal. 2 and 2, this is equal. 3 and 4, this is not equal. 4 and 5, this is not equal. 5 and 1, this is not equal. 6 and 6 is equal, and 7 and 7 are equal. So we got 1 2 3 4 position which need to be managed. So what could be the really optimal way of doing it such that it is really easy? Because if we see clearly in this problem, the 3 4 5 and so sorry 1 should be here in the sorted. This is the sorted and this is the given. So in the given 1 is here, but in the sorted it should be here. So if we see that in between we have a proper match, so one thing we can do is that we can just shuffle here to get an order, but that will not work because 1 is present at this side and we have to bring it here. So if we shuffle to the left side of here and right side, we implement that operation, then we cannot get 1 there. So what the best operation would be, which will be really optimal, that we first select the entire region where there is a mismatch. So and since previously it was 3 2 4 5 and 1, now we if we select this, then we can arrange this entire things in any order of our choice. But the only constraint is that 3 cannot come at this position, 2 cannot come at this position, 4 cannot come at this, and 5 at this, and 1 at this. So we cannot just do that. Other than that, we can do everything. So what we want out of this is 1 2 3 4 5. So we want to this get this order, but in this if we see this 2 had a match, that means 2 cannot place here back, so we cannot place directly to here. So what we will be doing is we will be handling this really smartly. We would be not making this from this, we would be first making this 2 3 4 and 5, and in the last we would be placing 1. That means the entire sorted order just shifted by one place. And so we would be taking one operation to form this, and in the next operation we would be again shifted back. Then and this would come ahead. So 1 2 3 4 5. So if we see that from this point to this we have changed the position of all the element. So those who were sorted, they have changed, and those who are not sorted, they are just brought one ahead or behind to their sorted position. So in this case this worked, but in no, this will also not work. We have to make something like this for this. So this would be changed. So basically what we want to say is that we will be arranging this entire thing in any order. Just the same thing should not come at the same position, and by applying the next operation we can easily get them back to their correct position. So this was the entire thing. So now let's take some bigger example, then that would give us even more clarity. So here it is a match, here it is a match, here it is a mismatch, here it is a mismatch, here it is a match, mismatch, mismatch, match and match. So now if we see that we have to do is we have to swap these two and we have to swap these two. So since this example was appears to be really simple, but it can be handled just the similar to this. So if we select this entire region and apply the operation ones on all of these elements, and since the sorted order is 3 4 5 6 7, but there is a match on 5 and 5, so in one operation we cannot make it like this. So what we will do is we can make any arbitrary permutation such that only this element is not at the original position and these all are also not at the previous position. So we can make like 5 6 7 and 4 and 3. This would work because all the elements which are, so 4 was initially here, here it is 5, so 4 is displaced, 3 was here, it is 6. So every element is changed in just one operation, and in the next operation we would be again making it in the sorted order 3 4 5 6 7. And again if we see the 5 was here, now 6 is here, 6 was here, 4 is here. So all the elements are positions are changed, so it is a valid operation and it is also sorted. So what now we can conclude is, so we will be working basically on this array in the solution. When we would be, so suppose 0 0 0 1 0 0 1 1 0 0 1, so we can actually do in just two operation. So this 0 means there is a mismatch and 1 means there is a match here. So in actually two operation only we can sort this entire thing by just following this, that in one operation make it a bit closer but not exactly to the sorted original position, and in the second operation we can easily get it to the correct by following this same approach. But we also have to take care of one more thing, that if something 0 0 none, if this was the case, that means this position was sorted and this was also sorted. So in this we had just only one continuous, so we can just apply one operation on these and make it sorted. So this was the edge case which we need to handle, and rest every mismatch from end start till end. So if we had a 0 here, then it would be ending here. This all thing can be handled by just two operations. So this was the main thing. Now let's get to the code for better clarity. So here is the code, and we will be understanding it in parts. So here we are taking the input, here we are making that flag array of this 0 and 1. So if it is same, we are marking it as 1. If it is different, we are marking it as 0. Now here what we are doing is we are just counting the number of these zeros interval. That means if we write it like 1 0 1 1 0 0 0 0 1, so we are just counting this how many zeros are there. So here it is 3 0, and then the answer would be minimum of count comma 2. So if the count is greater than 3, that means in this case then the answer would be 2, as we have discussed here. according to this, by following this same way, just making it slightly different than the sorted position, we can get this. So the answer would be the minimum of count and 2. And for this 1 also, even count would be 1, because since this has only one continuous zeros, so count would be 1, and minimum of 1 comma 2 is 1, so 1 would also work. So this was the entire code which was accepted, and I think everything was, I was able to make you understand. If anything is still not clear, do let me know in the comment section, and give this video a thumbs up. Do subscribe to the channel, as we will be regularly posting competitive programming material from this contest and other contests. Thank you guys, thank you for watching.